My name is Dendi, and I'm a grad student here at NC State. My major is financial mathematics. Uh, Previously, I've been working in an investment bank in the trading floor, but I hated how every day they only thought about money. So I think that going to grad school was the best shot. So here I am. I've been funded by the Department of State to come over here and study in NC State. And I know a couple of you guys who are from here, Stat Department or the Math Department, and several of you guys are the first time coming here from meetup.com. And right, so I hope you still come over next time and enjoy coming to this group. And we do this regularly on Friday. It's called the Statistical Learning Group, and it was founded by Dr. Post. And yeah, there's Jamie Jackson here, there's Joshua Day, and Neil Grantham. Right, there's one more, right? Professor Brian. Okay, so basically today what I want to talk about is on deep learning for images. So last week, Neil Grantham told us all about the theoretical part of what deep learning is and how neural network works and all this stuff. But I want to refresh on on a brief introduction on how we got here and what is machine learning actually. So if you knew that there's this problem in the millennia that we have a lot of data that we need to process, like gigabytes or petabytes of data each day, like in Facebook, Google, and it poses a problem that humans don't actually have the time, power to process those data. Oh, dim lights, sure. Is that all right? That one? All right. So, and these challenges are a lot of computer scientists think of this problem and, hey, why don't we use a computer to solve these stuff? And in the beginning, there's these computer scientists. So there's, like Neil told us last week, there's the concept of perceptrons, and actually it went to the neural network revolution, where these four main scientists, like from the left, he's Professor Yan Lechun from NYU, Geoffrey Hinton from Toronto, from University of Montreal, Yoshua Bengio, and Andrew Ng, who basically four of them made the Google brain. And if you've been going on through this thing on the internet, there's this Chronicle review last 2 weeks ago about Geoffrey Hinton and how his prolonged life work was for neural networks. So basically, there's this thing called a supervised way of machine learning and unsupervised way. And the supervised way is how we do it in the old ways, like how you defined, say, a fitting of a data using cubic spline. And so these old ways have pros and cons. First, you have to make a specific algorithm for them. And to regress, you should understand how the algorithms works behind them. And the pros in the early days were you need to understand all the statistical terms in math to do that. And it's easy to derive, and it has low computational power. You don't need like fast computers to actually run the models and get your output. But there's a cons here that you actually it is not useful for a generalized approach. For example, you want to have a model that understands patterns in data in speech recognition and data in images, you can't have one generalized approach to understand patterns in both data, because they're inherently different. So these four scientists thought, we can't use the old statistical approach anymore. We need to find something that is much more simpler in terms of algorithms that you can make that can run on all types of data. And this is where the neural network revolution goes in. So the million-dollar question is, can we devise this kind of algorithm? Is there a simple and a generalized way to do this stuff? And there's this revolutionary book called On Intelligence by Jeff Hawkins. It was published in 2000. He basically said that if you compare the old approach and the new approach, and you look at the brain, and you see that our brain actually does understand the data that comes every day in a very simple way. It only works within neural networks, and that's why he said that, like, for example, if you see the natural how nature actually works, they work in simplicity. For example, how the general relativity works. It is actually a simple idea of a curvature of everything in the universe. So there should be a simple algorithm to actually devise how patterns actually work everywhere. So basically, if you know Jeff Hawkins, he's the founder of Palm Computing, like the Palm Computing device, and he did his neuroscience in UCB, I think, and he basically devised what we know now as the foundation of neural science in neural networks. And now it's not merely a question of mathematics and statistics anymore, but it's also of a question of a lot of majors coming in together. And that's also why there's a lot of field that they're jointly connected into the field of machine learning, because say you need to understand how our brain develops from our evolutionary process. Think about it. How did our evolutionary process make this complex brain happen? And it's also a problem in neuroscience. It's a problem in physics. A lot of physicists come in, say Dr. Hopfield from Princeton. He devised what we called as an Hopfield network. And even it goes on and on to, like, if you read journals in machine learning, it goes to a question in philosophy and also even liberal arts. So there must be a new approach of this, and that happened in the early 70s, as Neil told last week too. What we understand now as neural networks. It's so there's a couple of them. It started from the perceptrons, and there's Hopfield networks. There's also Boltzmann machines, restricted Boltzmann machines. Basically, that has a simple algorithm that mimics how our brain works. So it fires if there's a pattern in it, and it gives a 0 if it doesn't. And there's this sigmoid function, like Neil told last week. There's a function in our brain that your neuron actually fires when you see stuff. And the reason behind intelligence is what we call parallel associative memory.